Okay, welcome. We are going to talk about container security, Kubernetes security, and Falco. So if that's not what you are here for, you're in the wrong room. My name is Degioanni. I am CTO and founder of Sysdig. I'm also one of the co-creators of Falco. So I've been involved in the project essentially since the beginning, which means a couple of years ago. My background involves open source and actually networking for quite a long time. In particular, I've been heavily involved in my past in Wireshark. I was one of the core team members of Wireshark, and I've done packet capture my whole life before starting Sysdig. What is Falco? Falco is a behavioral activity monitor with full support for containers and orchestration, with flexible notification methods, and it's open source. So we're going to spend the next 30 minutes essentially unpacking the content that is described in this slide. But before doing that, I just wanted to mention the fact that Falco is a CNCF Sandbox project. We've actually been accepted as a sandbox project pretty recently, like a couple of months ago. And that's the reason behind this is we want Falco to be driven as much as possible by the community, and we want Falco to be as integrated as possible in the modern stack, the stack that is essentially around cloud native and Kubernetes in particular. So when at the very high level describing Falco, often I use the metaphor of home security, right? So when we do home security, we want to do prevention, right? We want to prevent people from breaking in and coming into our house. Typically, we do that with like gates, door locks, bars on the windows, and stuff like that. And that's great, but often we also want to enrich that with some kind of way to detect and report intrusions. So typically for our home, we use stuff like motion sensors or interior cameras or stuff like that, right? So moving to the world of Kubernetes, definitely we want to put attention and focus at preventing intrusions. So we want passwords, we want two-factor authentication, we want image scanning, we want admission controllers, we want network policy, all of this kind of stuff that essentially makes us confident that our system is nicely protected. At the same time, things can happen, and when they happen, we want to detect and report these intrusions. So in order to do that with Kubernetes, you can use Falco. It's important to realize that both methods, the prevention and the detection, are of key importance and complement each other, and typically you want to use both. So Falco solves the second one. Why are both these methods important and complementary with each other? Well, a good example is this vulnerability. I don't know how many of you are aware of this vulnerability that was essentially released last week. Yeah, this is CVE 2018-12105, and it's probably the very first critical vulnerability released for Kubernetes. The disclosure and the fix came last week, and they were very quick and very instant. How it works, we actually managed, our research team at Sysdig has managed to reproduce this vulnerability. Essentially, I'm not going to go over all of the details of the vulnerability, but you can make a request to the API server for something on the kubelet, and you can generate a specific request that causes the kubelet to generate an error, in particular a 401 error. This error is reported back from the API server to the attacker, but the TCP connection is not closed. So there's a pending TCP connection that is now available for the attacker to talk directly to the kubelet. So as you can imagine, now that there's this TCP connection, we can craft a request, malicious request, to tell the kubelet to go and execute something outside our pod, outside our namespace, outside the domain where we have our privileges. And in this case, for example, in this example, I execute a touch of /bin/login into one of the containers. Let's try to actually take a look. So I'm logged into a machine that has a version of Kubernetes that has this vulnerability. So what I'm going to do is I'm going to run the vulnerability. And sure enough, I was able to essentially jump into a container and do a touch of /bin/login. OK, this happened. You have my word that this happened, right? So that's the problem. This system is a system where we did everything right? There's the right authentication, there's the right network policies, and everything else. Still, something entered in the system, and we don't know exactly what happened, right? So on the same machine, I'm going to run Falco, and then I'm going to run the CV again. And this is the simplest possible way to run Falco. We executed it as a command line tool on the same machine where essentially the Kubernetes cluster is. This is a single machine Kubernetes cluster. And now we can see that we have an event that was generated by Falco. And it's telling us that a file below a binary directory was open for writing. It tells us the user. It tells us the Kubernetes pod and container. It tells us the command, the full command. And it also tells us the file that was modified. So that's Falco in a nutshell. And that's why you need something like Falco in addition to everything else in a nutshell. OK? So interior cameras. How does it work? How did Falco manage to detect what happened after there was the break-in into this container? It's not trivial because containers tend to be isolated, which is a very nice feature of containers until you need to figure out what's happening inside them. Containers typically are immutable at runtime, but as we saw, very often they aren't. So we need a way to essentially understand what's happening and detect the anomalous behavior. Let's start by looking at how we deploy Falco. So we deploy Falco by running another container, another pod in our Kubernetes deployment. So here, for example, I have a simplified version of a host. This can be a physical machine or a virtual machine. There are a couple of containers that are running here. One is the Redis container. The other one is the nginx container. What you do is you tell Kubernetes, typically with a daemon set, to deploy one more container in each of your machines, the Falco container. The Falco container, typically when it starts, it detects the version of the operating system and deploys a layer of instrumentation inside the operating system. So at that point, you have something that is sitting underneath every single container and is able to detect a bunch of stuff that is happening inside the operating system. In particular, the main hooking point for tools like Falco or Sysdig is the system call interface in the operating system. System calls are, for example, I don't know, opening a file is a system call. Reading or writing from that file, that generates system calls. Establishing a network connection, that's a system call. Sending or receiving data on the network, those are system calls. As a server accepting a network connection, system call. interprocess communication, executing user activity like running commands. These are all system calls, right? These are all things that can be intercepted. How does this interception level works? In practice, as a final user, you just need to run Falco, and you don't worry about that. But under the hood, Falco instruments the system in a couple of different ways. Traditionally, we've done that with a kernel module that is automatically compiled and deployed inside the kernel. More recently, in the last 18 months, we've worked together with the Linux kernel community on an eBPF version of our instrumentation. eBPF is essentially a virtual machine that runs in the kernel of the operating system and allows to perform this kind of data collection in a way that does not require modifying the kernel, does not require installing a module inside the kernel, and even more importantly, is verified, because eBPF is just-in-time compiled, and before the just-in-time compiler kicks in, there's a verification step that makes sure that, that everything that you inject in the kernel is safe. For example, you can also only do a certain number of backward loops and stuff like that. So these are implementation details, but the result is that at this point, there's something that is able to collect every single system call and pipe these system calls to the Falco container. So let's actually take a look. And the easiest way to observe this behavior is by running Sysdig. As I was saying, Sysdig, I don't know how many of you are familiar with Sysdig as an open source tool? Quite a bit. So Sysdig is based exactly on the same instrumentation, but Sysdig is more like a TCP dump for system calls, right? So if I run Sysdig without any command line argument, I just, as you can see, get a very verbose list of system calls. But with Sysdig, I can use filters, very similar to what I do with the TCP dump or Wireshark, right? So I can do something like container.name contains Redis, for example. And now I'm reducing the list of data that I'm seeing to only the Redis container. As you can see, Sysdig and Falco are container aware, so I can scope these filters to specific containers. And for example, I can add and file descriptor dot type equal IPv4. And now we're only looking at the network activity of the Redis container. So as you can see, it's a pretty powerful filtering system that allows me to mix and match these conditions to observe and capture the data that I want. Very powerful troubleshooting tool. I suggest you to go take a look. Sysdig is open source as well. Falco builds on top of this capture system. So now essentially we are exploding. We're going inside the Falco container. We're exploding it and see what happens. So there's data, the system calls coming from the kernel. They are captured by a set of libraries. On top of these libraries, there's a rule engine that allows you to essentially create and apply rules. You write your rules, or you use the community-created rules. And the output is events, events that can go to syslog, file, standard output, shell, and so on. I'm running Falco here in this demo in the simplest possible way. So I'm just running in from the command line and getting the output on standard output. Of course, you will want something a little bit more sophisticated than that in real world use cases. If we go to the container, actually, let me now run Falco. So same machine. And now Falco is running on top of that. Falco typically runs on 24/7, and there's a bunch of rules that are enabled by default. So for example, here, let me SSH into one of my Redis containers here in my demo infrastructure, and immediately Falco is going to tell me, hey, somebody executed a shell into a Redis container and gives me all of the details. So rules. This is an example of a rule. Typically, it's pretty simple and pretty readable, as you can see. But as you can see, the key pieces are the condition, which is essentially something similar to the filter that I just showed before with Sysdig. And then output, where you can format essentially through a domain-specific language what you want to see as a consequence of the rule being met. Some example of conditions: a shell is running in a container, system binaries are overwritten, change of namespace, which means that some container is trying to impersonate a different container, non-device files written in /dev. Process tries to access camera. We can do this by essentially looking at accesses by specific processes to the video driver, essentially. So as you can see, there's a lot of flexibility and a lot of power in combining all of this kind of stuff. Of course, we don't expect you to write your own rules. What you can do is you can use the ones that are enabled by default. Falco comes, especially in Kubernetes, in the Kubernetes domain, comes pre-packaged with a set of rules that you can use out of the box. But of course, you have the whole flexibility to create yours. And there's also a bunch of rules that are more like application-specific that are not enabled by default, but you can go and just enable them in the configuration file. Now, that's great. Typically, we're KubeCon, so you would expect Falco to live somewhere inside Kubernetes, and you would expect an API server to be available somewhere, right? So one very important thing that Falco does is it can talk to the API server to fetch metadata. What's the purpose of doing that? In this slide, we have a slightly more complex diagram. We have many machines on the left, and every machine is running 4 containers. And here the color coding, I don't know how well you can see the colors on the projector, but the color coding is based on service, right? But you can assume, it's a Kubernetes service. It can be namespace, it can be replica, whatever you want. Typically, you don't want to approach things like they're depicted in the left side of the screen. You want to approach things like on the right side, right? So you want to reason in terms of services. You want to reason in terms of services when you define stuff and when you get the output, right? And in order to do that, Falco has knowledge of Kubernetes among many other orchestrators, and by using this metadata, allows you to essentially reason in that way. So let's go again to our machine. Let's stop this. And I want to show you, actually, I created a couple of custom rules here. The first one is manually downloading a tar file. So the condition is if the process is curl or wget, and a command is executed, and this command has arguments that include the string .tar, then emit an event. It's very simple. Of course, it has very false negatives and also a lot of false positives, but it's a simple one that I can use as an example, right? The interesting thing here is the output. So here, as you can see, I'm showing the username, but I'm showing also the namespace, the service name, and the pod name. These are fields that are, if you go to the Falco documentation, you can find all of those fields, right? So now I'm running Falco in a slightly different way. Essentially, you typically don't have to do this if you run like Falco as a daemon set or stuff like that, but I'm doing it manually. So I'm telling Falco, point to the Kubernetes API server to fetch the metadata when you run, so that you can resolve essentially those things. And then from inside my Redis container, I can wget, and sure enough, as you can see, I get an alert, and I can see that the namespace is dev, the service is ready, is Redis, and this is the pod name, Redis dash and so on. So again, this is just command line, so the value is pretty limited, but the importance is that the fact that Falco is able to emit these events with all of the context that you need. So it's not only a container with a name this long had an issue, or a container image at a specific issue, but you actually know the exact context in Kubernetes, which is typically what you need when you're going to go there and investigate your problem. Another example is I have a second rule, which is detect any process inside that is executed inside the Redis container, which is not called Redis server. Typically, you don't want anything other than Redis server to be deployed, to be executed inside the Redis container. Now, I customized this rule because absolutely I want my containers to be mutable in production. So it's really bad if somebody executes whatever, wget or cat in a production container. But maybe I want to relax this because I want my developers to be able to do this, and I don't want to generate a notification, or I don't want to generate an action, right? So as you can see, the condition here tells me that the namespace needs to be different from dev, all right? So now we execute Falco again, and as you can see, no activity is logged for this specific container, because here, as you can see, we just logged into Redis in dev. But let me go to actually a different Redis, which is in a different namespace. And now I have the sharing container again. But now, as you can see, I've done dev again. At least we have the proof that it works. Let me find this one. OK. And now I have a log of all of the commands that are executed inside this container. So these containers live in the same machine. They are just two different colors, as depicted in this slide. And Falco will apply two different rules by recognizing the color, by understanding the color, by fetching the data from the Kubernetes API server. OK? Now, since we are talking to the API server, we can add another feature. So what we've recently released, really like a few weeks ago, is we embedded a web server inside Falco so that Falco can receive events from Kubernetes. In particular, we included the ability to ingest Kubernetes audit logs and to treat them as Falco events, so that you can write a condition like this one, which is create or modify a config map with private credentials. So now, same syntax, same ability and flexibility to create rules, ability to combine these with the rules that are coming from the system calls, but data that is coming from Kubernetes. So this becomes much richer and much more powerful. I won't have time to demo these for you or to show the details of these, but I highly recommend there's another session on Thursday that will be focused specifically on this. So how to leverage Falco in conjunction with Kubernetes for with this specific functionality. So please mark the date. This is on Thursday. Now, we've talked about how it works. We've talked about the architecture. We've talked about exactly how you can create your own rules and so on. At the same time, we've demoed it for the moment on a single command line, right? So the question that you probably have is, OK, what do I do with this, right? So first of all, as I was saying, the alerts, the rules have two components. One is the condition, and the other one is the output. Output is, as you saw, is completely flexible. When I do specify a rule, the output can be a mix of like strings and then a syntax that is a bit like similar to the printf syntax, where I can specify arbitrary fields. And again, the documentation contains the list of fields, and there's hundreds or thousands of them. At the same time, there's an element of configuring Falco to output the events to different targets. In particular, on the local machine, you can do syslog, you can do file, You can do standard output, which is what I've done. You can also execute the shell commands. So you can, for example, tie it to sending an email or whatever you want. At the same time, I have a few examples of a little bit more sophisticated deployment of this. I am, again, not going into all of the gory details of this because I don't have time. But as you can notice, at the end of the slides, I have a link to blog posts that describe essentially how to set up Falco in the specific way. So the first way is being able to emit the events and pipe them into Fluentd, and then posting these events to Kibana. At this point, you have essentially a centralized collection and logging, and then from Kibana, you can create your own dashboards and your own reports. You can have alerting and a bunch of stuff like that. The second way, this is actually a blog post that was published by Amazon that shows how to use Falco on AWS by using a net sidecar that pushes the events to AWS Lambda. And then we can have functions that can perform a bunch of stuff. For example, on one side, send notifications, for example, on Slack using webhooks. And on the other side, execute some form of reaction using the Amazon EKS API, for example, to, I don't know, taint the machine or stop the pod or kill the container or arbitrary stuff like that. Another example, which is similar, this is a blog post that we published pretty recently, is the ability to collect the data, pipe it to nets, and then use kubeless instead of Lambda for the serverless handling of the events. And then similarly, from one side, maybe send them to some kind of enterprise event routing tool, like, for example, Phantom from Splunk. And at the same time, talk to the Kubernetes API to perform actions. Again, there's a blog post that describes that, and there's all of the details. So you can go and take a look at that. Before, we're almost out of time. I want to leave a couple of minutes for questions. But before I end, so first of all, a little bit about roadmap, in particular, immediate roadmap. As I've mentioned with the KubeCon events, we are working on making Falco richer and richer in terms of the data sources that it supports. So we start with system calls. Now we do Kubernetes events. We're looking into adding stuff like service mesh events, like Istio, Envoy, and that kind of stuff, and also potentially application-level events that you can inject in different ways. Similarly, we are working more and more to try to integrate Falco in a way that is as seamless as possible with the ecosystem in a general way. So messaging services like SNS, Google PubSub, or Kafka, we see quite a bit of demand. For example, Kafka is quite used in production in the enterprise, and it's a great destination for Falco events. And then you can consume them any way you want. And login services like Elasticsearch, Splunk, Stackdriver, and so on. Web services like HTTPS, gRPC, and so on. And of course, thing that is always a big focus for us is rules, and keep making Falco richer and deeper by keeping working on the rules. And from this point of view, again, the rule engine and the rule system is completely open source. It's on GitHub. It's community-driven. So go take a look. And if you write your own rules, we always welcome contributions and pull requests. All right. Community links. So this is where you find all you need with regards to Falco. Most of the stuff is on GitHub, as you can see. We have a Slack. We have, you can go to falco.org to find all of this information. So with that, just again, there's another session on Falco. We're very excited to have become part of the CNCF, and we're looking forward to working with the community. Stopping here and see if there's any question. Yes. Maybe we need to use the microphone.
Do you have plans also for enforcement, or are you still in monitoring only?
If you look at the basic architecture slide, this is sort of a really nice place to sit, right? Because we're here, we are deployed essentially at the transition between processes running on top of the operating system and the operating system itself. So there's definitely an opportunity to do enforcement. The kind of enforcement that you do depends on essentially how complex you want to make this. But definitely in our longer-term roadmap, there's the idea of being able to block at a certain point. Yes?
2 questions. First, what's some overhead numbers in terms of additional latency for this stuff?
Yeah. So marketing answer is low. The more nuanced answer is it depends. Because as you can see from the architecture, this is something that sits here and listens to all of the activity that all of the processes do and captures it and applies a set of rules on top of that, right? So the overhead depends on 2 factors. One is how much activity there is going on here, and the second one is how many rules you have. So typically, at the same time, this is heavily optimized for production use. Sysdig has commercial products that are based on top of Falco. So our own Sysdig Secure is essentially based on Falco as the engine. And we have, like production uses on like big companies. So typically, the overhead that you can expect in terms of CPU utilization is probably a few percentage points of CPU utilization. And the memory overhead is probably in the tens of megabytes, something like that, just to give you a ballpark. But again, there's the caveat that this is it depends a lot on how many rules you use and exactly the footprint of the machine.
Yeah, yeah, that's perfect. And second is, are you going to post these slides on the Sketch thing or no?
Yes.
Perfect. Thank you. This was great.
Thank you. There's a couple of more here in the front. One there in the back too.
I was just curious if the eBPF model is everything going to move to that direction eventually?
Yes. Absolutely. That's our goal. The kernel module will always be there to support the older kernels. Essentially, eBPF is started stabilizing in the the requirement for Falco to run is essentially 4.14. So it's like 18 months ago, something like that. So for the older kernels, it's still nice to have the kernel module, but for the newer kernels, we're moving toward eBPF. By the way, the eBPF scripts are on GitHub too. They're open source as well, so go take a look. It's pretty crazy.
Someone over here.
So my question is, does this require a custom build kernel version or?
No.
Okay.
The only thing that you need to do is run the Falco container. That works on pretty much any version of Linux. If you can run a container, you can run this. And there's no customization in the kernel. It's all transparent. The instrumentation is completely transparent. And you don't reboot the machine. You don't restart your applications. You don't do anything. It's completely transparent.
Anyone else?
Just about the kernel module, do I need to have the kernel headers? Like, when do I compile it?
Yeah,
Who does it?
So what happens is there's a couple of ways this happens. Typically, when you run the Falco container, the container detects the version of the kernel, downloads the kernel headers, compiles the kernel from the source, either the kernel module or the eBPF scripts from the sources and inject it in the kernel. There are some kernels where you don't have, for example, the kernel headers, or you don't want to download the kernel headers. In that case, it's possible to essentially download the precompiled version of the kernel instrumentation for that operating system, and you don't need the kernel headers. But typically, by default, it's done by the container when it starts.
Probably last one.
Is there a minimum kernel version that we need in order to run this?
2.6. What's that? 2.6.28, which in theory you can do to 6.18 because Red Hat backported the trace points to Red Hat 5 essentially.
Wonderful.
But
Thank you.
it's like 15 years, you know.
Please don't.
Exactly. Hey, we're hackers, right? All right, thank you very much, guys. And we have a booth down in the vendor area. You can go there and take a look and get a demo if you want, or get more details if you have more questions. Thank you.